Hello guys, my name is Felix, and in this series of tutorials I'll be teaching you most of these machine learning algorithms. We are not just going to be coding, but also we'll look at the intuition behind these models. We'll be looking at some mathematical concepts and finally how to implement them in codes, so that this will prepare you for all your interview process, not just knowing how to write code, but also know what is going behind the scenes once you are coding. So if you are glad about this series, just give me a thumbs up and also subscribe to this channel so that you don't miss any of these tutorials. Bear in mind, I don't want you to miss any of them because they are just going to be sequential, and missing one go a long way of distorting your understanding. So make sure you subscribe and you keep your notification bell icon on so that I don't miss any of them. Ready to do it? Let's get right into it. Alright guys, and welcome back. So if you have made it to this point of the tutorial, I can clearly see you are ready to learn AI and machine learning. So let's just look at what we'll be learning today. So today we'll be learning about a simple linear regression algorithm, okay? We'll look at the math behind it. We'll also get our hands dirty later on in writing the code to implement this. But let's first focus on the intuition behind this particular algorithm and how to implement this algorithm with our bare hands. We are using math of course. Then afterwards, we'll see how to implement it in code. So first of all, let me just minimize this or just push it to the right hand side. I'll just put it here. And the first question here is that what is simple linear regression? So if you are in an interview, ML or AI interview, and you are asked, what is simple linear regression? Cool down. This is a very simple question. You are fortunate, so this is how to answer it. You have to tell your interviewer that, okay, simple linear regression helps you to find a relationship between an independent variable and a dependent variable. And I'll be explaining this into details by just writing some things later on this board. But just tell him simple linear regression helps you to find a relationship between one independent variable and one dependent variable. So let's look at what that means. Let me just choose the pen, and for that, before we even start, you guys to pardon my handwriting. I'm using this pad for the first time, so let's just all cope with it. I'll get better over time. So let's say you have x. In this case, we'll say x is our independent variable, okay? Then we have a line here. Let me try my best to make this straight. And over here we have y, okay? So what we are trying to achieve here is that we have some values for x. So let's say we have 1, we have 2, we have 3, 4, okay? And then for y, let's say any number we have for x is times 2 of the number y. So if it's 1, we'll have 2. If it's 2, we'll have 4, 6. And then let's say for 4, we don't know the value, okay? So we put question mark here. We don't know the value for 4. So what simple linear regression is helping you to find is that linear equation that will help you to find each value for y, okay? So in this case, what we mean by dependent and independent variable is that, okay, the values of y depends on x, okay? So in this case, we call y here our dependent variable, okay? So to find y, you need to first know the number for x. So in this case, y is strongly depending on x, okay? So that's why we call it what? Dependent variable. And for x, we call it independent variable because it doesn't depend on y, okay? All right, so that's the fact we've just established about dependent and what independent variable. Now, the simple question is that how can we find this equation? Okay, so how is this algorithms possible to find this equation? And we have been using a lot of libraries which have simplified this process. We don't know what is going on, but today I'm just going to show you the math behind this. Okay, so we are all familiar with the equation of the line. So let's say y is equal to mx plus if it's b or c, let's put c. Okay, so we are all familiar with this equation, and with this equation, this y here is our dependent variable we are trying to find. So M here is our gradient, all right? So M is our gradient we want to find, and C here is our Y-intercept. All right, so in order to find this Y, we have to be able to find the M, and we have to also be able to find the C, which is the Y-intercept, okay? So first we have to find M, and M, for the formula for M is just y2 minus y1, and I'll explain this, all divided by x2 minus x1. Okay, so this is the simple formula for finding the gradient. Okay, and to find this gradient, we can come and utilize some of these numbers here. So let's say for y2 we'll be taking 4, for y1 we'll be using 2, then for x2 we'll be using 2, and for x1 we'll be using 1. So if we should put that into the equation, we'll get m to be something like 4 minus 2 divided by 2 minus 1, and this will be equal to 2. So from this equation we can find our gradient, which is this m here, to be what? 2. Okay, so the value for this gradient is 2, and we can just utilize this number to find this gradient. Okay, the next thing is, how can we find our y-intercepts? Okay, so now that we have this gradient, we can also plot in some of the numbers to find our y-intercept. So now let's say our new equation, let me come down. Our new equation, which is y, will be equal to 2x plus c. Okay, so we can just do change of subjects and put some of these numbers here in order to find our c. So let's assume we are using y to be 2 and we are using x to be 1. Then we can just simply have 2, which is equal to 2 into bracket of x, which we are substituting to be 1, plus c. And in this case, our c will be equal to 2 minus 2. And finally, c here will be equal to 0. Okay, so now we have the value of c as well. So our new equation will be y equals 2x plus 0. Okay, so our y-intercept here is 0, our gradient is 2, and now we have y, which is our dependent variable. So anytime we want to find this dependent variable, we need to use this particular equation. All right, so let's test this equation and see if everything is working great. So in that case, let's first test it for a value of x, which is 1, and see if we'll get y to be 2. If that works, then we can now use that same equation to predict the value for this 4 right here, which we don't know. So we are taking x to be 1. So in this case, our y, which is our dependent variable, will be equal to 2, and we are taking x to be 1. So I'll put 1 here, plus 0. Okay, so y here now will be 2, 1, which is the same as 2, plus 0, and our y is equal to 2. So this actually validates that the value for y with respect to x, which is 1, or in regards to s, which is being 1, is 2, and that is correct. So if we have to use simple linear regression to find the value for y when x is 4, then we just have to use x to be 4, and for that I'll come right here and I'll say when x is equal to 4, our value for y will be y is equal to 2 into bracket x is 4, and then plus c, but we know our c is 0. Okay, so our y will straight off be equal to 8, and you can see how simple it is now to find the value of y. Okay, so this is exactly what simple linear regression is about. This is the problem simple linear regression is solving. It helps you to find the relationship between an independent variable and a dependent variable. So let's quickly recap. So we said first, simple linear regression helps you to find the relationship between one independent variable and one dependent variable. And we said in this case, our independent variable is x, and we have some values for x, 2, 1, 2, 3, and 4, so on. It can be so on. It can be a very long data. In this case, we are just using this for an example. And we said our dependent variable, which is y. And the reason why is a dependent variable is that to find the value for it, it depends on the value of our x. Okay, so that's the main reason why we call it dependent variable. The values here depend on other values, which is x in our case. Okay, and we established the fact that for simple linear regression, you can use this particular equation, y, and y here is your target or your dependent variable, and is equal to mx plus c. So we said m here is our slope, okay, and x here is our independent variable, plus c here is the y-intercept. Okay, so that's c. And we said to find the slope, we have to what? Use this particular equation, y2 minus y1 all divided by x2 minus x1. And we established the fact that we can use some of this sample data to find the slope. So we just pick y2 as the second number and y1 as the first number for our dependent variable. And the same thing, we pick 2 here as the first number and 1 here as the second number for our independent variable. And that helps us to find our slope to be 2 right here. Then we move on that, okay, we find our slope, but we also need to find our y-intercept. Okay, so y-intercept is the point on your graph where s is equal to 0. Okay, so that's one thing you have to know, is the point on your graph where x is equal to 0. So to find that, we also just substitute some values for our dependent and independent variable, and we find out that, okay, our c or our y-intercept is equal to 0. So now, establishing this fact, we get our new equation to be y is equal to 2x plus 0, and we just have to now substitute any value of x into this equation to get the corresponding value for our dependent variable. Okay, so that's what we've done, and we've tested it with 1, and with 1 here you can see the result is 2. We also went ahead to test it with 4, which we don't know the answer, and we found out that 4 the answer is 8. So with 4 the answer right here is 8, and we know our equation is working. So this is the intuition behind simple linear regression. All the mathematics you need to know is pretty simple, just equation of the line. We have other methods of finding this gradient and this y-intercept as well. We have other by using the standard deviation and so on, but I think this is the simplest one you need to know, and this how simple it is to find this particular equation. Okay, the linear equation. So this is the theory aspect of this particular tutorial. Now we'll move on to how to code this in Python. So we'll be using the Python programming language to implement this particular information we've just demonstrated here. So let's get into that. All right, so now it's coding time, and let's try our best to implement what we've learned using the Python programming language. So over here, I'm using Visual Studio Code, and I've just created a folder on my desktop called ML series, and I've dragged that folder into Visual Studio Code. So the first thing I will do here is to just open my terminal. So I'll open the terminal, and I'll go ahead and create a virtual environment. If you don't know what virtual environment is, I suggest you look at it. I have a video on it on my channel, so just look at it, and generally it's very simple to understand. So for that, I'll type Python -m v and the name of my virtual environment. So I'll just call it ML and hit enter. All right, so our virtual environment gets created, and you can see the name right here called ML. The next thing to do right here is to activate this virtual environment and install any package that we will need. So to activate it, I'll just write the name /scripts /activate. And this will activate my virtual environment for me. So right from here, I can go ahead and install any library that I want. So we'll need NumPy for this particular tutorial. So just write pip install NumPy, hit enter on this, and this will go ahead and install NumPy for us. So you can see it's collecting the packages, and our installation will be done in no time. All right, so NumPy is installed. I'll just clear this. terminal, and that's it. So now let's try to implement whatever we've learned. For that, I'll create a new file and I'll call, no, this should be inside here, over here, and I'll create a new file. So let's call this file simple regression.py. Okay, I think it will be good to add the linear, so simple linear regression. Okay, so that's the Python file we'll be using, simple linear regression.py. And since we've installed NumPy, we just have to import it. So we write import NumPy as np, and that's it. Okay, so let's go back to what we've done. So we have x and y variables. So x is our independent variable and y is our dependent variable. So let's create those variables. So we have x, and x will be equal to np.array, and inside here we can have some numbers. So for x we have 1, 2, 4. So let me just be checking. So we have up to 4. So 1, 2, 3, and 4. And we'll do the same thing for y. So the first thing we did right here is to find our gradient. Okay, so let's try to write a code that will find our gradient. So for that, we'll define a function and we'll call this function gradient. And this function will take 4 different numbers. So we'll give it x1, y1, x2, and y2. Okay, so that's what this function will take. And it's going to just return our gradient. So looking at what we have here, our gradient is what? Y2 minus y1 divided by x2 minus x1. So let's just write that. So this function will take these 4 input parameters and return to us this particular answer. So that's all our gradient is doing, and that's what we've tackled right here. So that's exactly what we have just implemented in Python. The next thing from here is to find our y-intercept. Okay, so we have to also do that. So let's just define a function. I will call this function y-intercept. And this y-intercept will take our gradient, and we've written a function to do that. It's also take a value of s and a value of y. So that's all the parameters this function will take. And this function now has to return us our y-intercept. Okay, so let's look at what it should return. So it should return us 2 times the s value we passed, and then we'll subtract the y value from it. Okay, so that's exactly what this particular function is to return. So this function should return to us 2 multiplied by, and this 2 here will be our gradient. So we just give it gradient multiplied by x, and then we subtract y from it. Okay, so this is all our y-intercept is about. It should return to us 2 multiplied by our gradient minus a certain y value. Okay, all right, so now we have a function for our gradient, we have a function for our y-intercept. That's looking fine. So let's maybe call this function and get these values. So first we'll call the gradient, and I'll just store this in this one called a variable called gradient value, and this is equal to my gradient. And inside this gradient now we need to pass the values x1, y1, x2, y2. Okay, so what we did here is that we use the value 4, 2, so 4 and 2 for our y, and we use values 2 and 1 for our x. So over here the s1 we've used is 1, and the y1 we've used is 2. Then x2 we've used is also 2, and the y2 we've used is 4. Okay, so that's what we've used. Let's cross check. So you can see we've used 4 for y2, 2 for y1, and 2 and 1 for that. So I think we are correctly doing it. So 4, 2, and 2, 1. Okay, so these are the values we just need to give this function, and we can just print gradient value get. So we are expecting to get 2 because we have just done the same kind of thing. Okay, so you can see we had 2 exactly here. Okay, so the next function we need to call here is our y-intercept. So I'll just call here y-intercept value. and this is equal to our y-intercept. We need to pass in gradient value as one parameter, and also we can pass in a value for x and y. So let's pass in the exact values we've passed here. So over here we've passed x to be 1. Okay, so we've passed x to be 1 and y to be 2. So let's just put in the same value. So our x we've passed is 1, put 1. Our y we've passed is 2. Okay, so we can print these values to as well. And I can just do f string so that this will look good. Okay, so this is just like editing the output so that we can see them so well. So let me quickly rerun this again. And over here, you can see we got our gradient value to be 2, y-intercept to be 0. So that's exactly what we've gotten here. So you can see y-intercept is 0, and we got our gradient here to be 2. All right, so we are almost there. The final thing to implement now is the final linear equation that we can just plug in any x value and get our answer for a predicted y value. So that's all simple linear regression is about. So we define another function. I will call this function linear equation. And this linear equation should take in our gradient value, should also take in our y-intercept value, and finally it will take an x value. So for any given x value you give it, it should be able to predict the y value. Okay, and bear in mind for gradient value we had all of them here. We've defined a function to find all of them here. Okay, so this function now should just return us this particular equation we've solved here. So y is equal to 2x plus 0. So in our case, our 2 here is our gradient, our 0 here is our particular y-intercept, and for any given x value, it should return that. Okay, so this should return as our gradient value multiplied by our given x value. Then we have to add our y-intercept to it. Okay, so this all these functions should return us, and with this function we can be able to predict any future y values for our given problem. So now let's just call this function and try to give it the value of x, which is 4, and see whether we'll get a prediction for y, which will be 8. We have done that already, so let's see. Let's try this function out. So I'll just call it my result is equal to our linear equation function, and for gradient value, gradient y, I'll just give it, and for given x value, so now I'll give it a given x value to be that's 4, to see if we'll get it. So let's just put in 4 here, and I'll print this. Okay, so our predicted value is the result we'll be getting here. So let's quickly run this and see. Let's run this and see. So you can see our predicted value is 8. Okay, so our linear function is actually working, is being able to predict the value for y for us, and this is what simple linear regression is about. So let's say we give it another value. Instead of 4, we give it 5, and we know for 5 we should get like 10, because each value in our x variable is times 2 the value in y. So let's see. All right, so we are getting 10, which is correct. Okay guys, so this is how to implement it. If you have some questions, kindly drop them another comment section, and also this code and every resource we've used here will be on my GitHub repository. Just follow the link under the description and you have access to everything you've just watched in this tutorial. Thanks for watching. Consider subscribing and also share with others. I'll see you in our upcoming tutorial. Bye.